Sometimes, instead of addition and subtraction, what we have is a situation where we are multiplying two functions together, and we prefer not to multiply them out. So let's say we have y equals 4x minus 2x squared times 3x minus 5. Now, it wouldn't be a big deal just to multiply these together using FOIL or distribution and then take the derivative of each piece to find the derivative. Right, we could do this without the product rule. But we can also do this by using what's called the product rule. Notice in this case we really have two functions. We'll call our first function f of x, 4x minus 2x squared, and our second function g of x, in this case 3x minus 5. So this is the product of two functions. To find the derivative using the product of two functions, it always follows this pattern. It's always the derivative of the first, so in this case f prime of x, times the second, times g of x, plus the derivative of the second times the first, so in this case f of x times g prime of x. Let's apply it to our specific situation. So y prime in our specific case, the derivative of the first of 4x minus 2x squared would be 4 minus 4x times the second function, which happens to be 3x minus 5, plus the derivative of plus the first function, in this case 4x minus 2x squared, times the derivative of the second function, in this case 3. This is an expression for the derivative, and in some cases is sufficient. Let's simplify it though, just to clean it up. If we FOIL these first things together, you end up with 12x minus 20 minus 12x squared plus 20x plus 12x minus 6x squared. And when we combine like terms, the derivative would be equal to negative 18x squared plus 44x minus 20. Just one thing to note, if you haven't noticed already, that if we had expanded the original function, y equals 4x minus 2x squared times 3x minus 5, we would have a cubic equation. And notice its derivative is a quadratic equation, or something to the second degree. And so when we're taking derivatives, you should see that the degree is usually, or tip is, one less than what you started with when you have a polynomial. There's a direct relationship there. Let's do one more with the product rule. Let's consider x squared. No, let's do option C. So we've got that f of x equals 3x squared minus 2x plus 5, and it's being multiplied by negative 5x to the fourth plus 2x cubed minus 7x squared plus x plus 2. Now one option would be to multiply this out, but instead we'll use the product rule. So f prime of x is equal to the derivative of the first function. In this case that would be 6x minus 2 times the second function. So in this case it will be negative 5 x to the fourth plus 2x cubed minus 7x squared plus x plus 2. And it's this plus the first function, in this case 3x squared minus 2x plus 5 times the derivative of the second function, which would be negative 20x cubed plus 6x squared minus 14x plus 1. And I can imagine some of you saying, do we have to clean this up? And I'm going to say, as a general rule, don't spend time simplifying things unless necessary. Although there are times when it's so easy to simplify that you really ought to simplify. But this would be one of those things where it's too easy to make a silly mistake and unnecessary.